This conference will now be recorded.
Okay, welcome back. Good morning. I created the cluster just now. Let me copy the cube config. Cp to is to the location hash cube slash config. Okay, kubectl get nodes. Okay, got ready. So last class we were discussing K8 resources storage. And we discussed we discussed empty directory host path, and we mounted EBS volume, and later we discussed EBS PB. Okay, if you have the volume created, you will create the PB, and then you will create the PVC, and you can claim that to your pod. This is the static approach, and then later we created the dynamic approach using storage classes. Okay, so we have already some storage classes available with the Kubernetes cluster. Then I just created PVC that will create PV automatically and attach to the pod. This is the dynamic way. And that one, the recycle, the policy was delete. And then we created a policy again that is retain. And we created our custom storage class. And we created PVC and PV attached to the pod. Okay, so EBS has some limitations we already discussed. The limitations are your your EC2 should be attached to that EBS, and wherever your EC2 is running, the EBS also should be in the same availability zone. That is the limitation, and you cannot get the policy like read write many, read read many. Those policies you will not get. You can only get read write once. Read write what is it once. Okay, so with these limitations we can go for NFS storage. NFS is like EFS in AWS. Okay, so before this let me do one thing. So now from today class we can go for EKS. We will create the EKS cluster. Let me do one thing called EKS client. I'll create one instance EKS client. Because the EKS provisioning will take 20 minutes time. So within we will create the cluster and we will discuss other topics. EKS client.
Bro, whatever you cluster created mini cluster, mini cube that is related equals to EKS cluster also, right?
Minikube is equal to the on-premise cluster.
Okay.
EKS is
This
the
is
service from
okay,
AWS.
AWS. Okay.
Yeah.
We can use EKS also, right, for the cluster. Whatever the parts we are creating, all the stuff we can use EKS also, right?
Yeah, from today's class, after completing that EFS topic, we will use EKS cluster.
Okay, for the
If
practice
you are,
purpose also, right?
yeah, if you are using AWS, mostly everybody uses EKS cluster. If you are
Okay.
using Google Cloud, then they will use GKE cluster. But the concepts are same.
Okay. We
Okay.
can go with either EKS or mini cube.
No, Minikube. Minikube is only for practice. EKS is for the real time.
Okay, bro.
Okay.
What I understood. What I mean, right? So previous classes we used for different cluster, right? practice also we can use EKS also, right? I mean previous classes
Yeah,
also.
for
If
practice also
you
you can use EKS. Yeah, yeah, you can.
okay, bro, got it, got it.
Okay, so now we have to do AWS configure here. Okay, so I have something. Okay, I'm stopping the screen for just to give these credentials for 1 minute max. Okay, I configured AWS, and then AWS configure I have given the keys, and we need to install EKSCTL. So mostly we use EKSCTL command line or something configuration file to create a cluster in AWS EKS cluster. So there are two ways mostly we follow, either Terraform or EKSCTL command line tool. First I'm creating this one, installing EKSCTL. Okay, install EKSCTL, create cluster --name demo EKS, and then region AP-south-1. Let me take the help first. So you can read this. You have a lot of options to create the cluster, but usually we will have an AML configuration generally in the most practical way. But for now, for practice, I'm going with the command line. Later we can see all these options, how to create the like production level cluster. Okay, nodes. Number of nodes I will take are 3. Okay, EKSCTL create cluster --name demo EKS -region AP-south-1, and let me take the minimum nodes I need are 3. Okay, now this command line will create one EKS cluster in AWS with 3 nodes. Okay, so it will take around 15 to 20 minutes. Within that time, let us discuss the EFS. Till now we have seen EBS static way and then dynamic way. Now let us go for EFS. EFS is nothing but NFS. So I will recap the storage. You know, empty directory, host path, and this external storage is very important. You will often face this question: what is persistent storage in AWS? So as a Kubernetes user or DevOps or cloud user, you no need to understand how the actual storage works. How we have a lot of storage, NFS, and then SIF. There are a lot of storage implementations outside in the market. You no need to understand each and every implementation, how to create, how to manage that storage. So that's why Kubernetes is abstracted that all the responsibilities from the administrators or users, and they created persistent volume and persistent volume claim and storage classes. If you have storage class, that means it's a dynamic way. If you don't have storage class, that is static way. For example, I create a storage here outside of the Kubernetes cluster. Like you are the Kubernetes administrator, you ask the storage team, I want this storage. Then they create the storage and they will give the details to you. Creation, management, maintenance, everything is the storage team responsibility. What you do is to manage it from the Kubernetes layer, you will create persistent volume. Persistent volume is the Kubernetes representation of the external storage. Okay, it's a physical. Persistent volume claim is the pods can use this PVC to claim the storage. Okay, though that is the difference between PV and PVC. PV is physical, it is the Kubernetes representation of external storage. PVC is logical, which will be used by the pods to claim the storage. Okay, and then storage class, it's a dynamic way. Instead of your cluster external storage administrators give the storage to you, if for example if yours is a small project or a dynamic project which use advanced technology, you no need to have the dependency on storage team. Using storage class, you can directly create the storage like we did here in our custom SC. I created the storage class and then directly I created PVC. In this dynamic way, PVC will create PV for you. Okay, that is the difference. So when someone asks you, there are two ways of provisioning. One is static and one is dynamic. In static way, storage administrators will create the storage and give the details to you. Then you will create PV and PVC. In a dynamic way, you will create the PV using PVC and storage class. Okay, that is the difference. I can write it in a written format and then I can upload to the readme file later. Just understand the difference for now. Any doubts till now? Ravi, Funny, Abhishek, is it clear? PV and PVC. If you are creating PV, that's a static. If you are not creating PV, that's a dynamic. That is the
Okay,
simple
sure.
difference.
Okay, sure.
Yeah. Okay, now we will go for EFS. First, we need to create one EFS. This is very simple. Okay, create file system. EFS demo I'm giving. The VPC should be where our Minikube VPC, and then yeah, create it. And security group, we need to attach from our Minikube, right? So let us see the security group. Same security group you need to give here because we are accessing from the Minikube. Is it created? Yeah, it's created. I don't see edit option here. Okay, edit here. You should see the network edit option. Okay, still creating. Now the security group is this one, my mini cube. Okay, so in this security group just make it allow everything. Okay, so I created EFS and then I changed the security group. Now I need to create PV and PVC. So this is static provisioning. We need to create the storage EFS and later we need to create PV PVC. Okay, so this is the static way. If it is dynamic, you don't need to create PV, you don't need to create storage. PVC will take care of everything. Okay, now let us go to documentation, Kubernetes persistent storage. Here there is no example for EFS. Let me take Kubernetes persistent volume EFS. Here also it's not there. Okay, this is one. Okay, API version persistent volume, just give my PV and then storage 5 GB, volume mode not required, access mode, read write many you can give. Persistent volume recycle policy, storage class name is not required. Mount options also not required. NFS can give the root directory. What is the NFS server? If you go and check here, you will get this one. This is the server. Okay, this is the PV. Now let us try to create this PV. kubectl apply -f 07. kubectl get PV. Okay, PV got created. Now we need PVC. PVC, just let us copy from this and change it. This is PVC, my EFS claim, read write many. You want 2 GB. Storage class name you can keep empty. Okay. Now let us apply this again. PVC is bound. You got your EFS claim, and then yeah, you got this. But EFS actually it is elastic. You can go up to any memory. Okay. Here, whatever the number I shows here, these are dummy. EFS is elastic. It can go to any extent. Okay, now let us attach to this pod. Let us take one pod. Okay, my EFS claim, and then yeah, that's all. I'm claiming the volume and I'm mounting it to the Nginx. Now let us check the pod as well. Container creating. Okay, now running. So it means it attached. You can go and check kubectl exec -it my pod bash. Okay, you can see it is attached. But if you see the memory, this is too much. It is showing the entire EFS of AWS because you can go to any extent with EFS. But with EBS, the volume is always limited. Okay, so this is the EFS static way. There is EFS dynamic way also. Instead of you go and create the EFS storage and create PV, you can create some storage class, and then from the storage class, you can directly create PVC. Okay, but for that I need some more concepts to discuss. We can discuss this again in a future sessions. EFS dynamic way. Okay. So this is all we have done with Minikube. Now we can go and practice with EKS cluster. And once we are good with EKS cluster, next we can go and discuss EKS production level cluster. So for now, I am provisioning, right? So it's still taking some time. Already 13 minutes is over. It may take 5 more minutes. Okay, now if you go and check it, EKS. It's active. These nodes are getting created, 3 nodes. Any doubts till that time? Not only this concept, like all the concepts till now we have discussed.
No, I'm good, bro.
Okay. Thing completed. So for EKSCTL to work, you should have AWS command line and configure AWS so that EKSCTL command will have the AWS access to create the resources. And later you should have kubectl also to connect with the cluster. Okay, kubectl not found, but still I think it have created the .cube directory. And now we need to install kubectl. kubectl version client. Okay, it is installed. Now let us see kubectl get nodes. Okay, so there is some defect with this kubectl command line. When you face this error, if you just search here, they will suggest you to update this one. Inside kubeconfig, there is v1 beta 1. You need to change it to v1 alpha 1. Okay, I think v1 alpha 1, I think it is. You need to change to v1 beta 1. cd.kube vim config. Here it is alpha 1. You need to just change it to beta 1. But in some kubectl versions, it will ask you to again change to alpha 1. Okay, but remember, whenever this error comes, you just switch between v1 alpha 1 and v1 beta 1. That's it. kubectl get nodes. Again some error. Okay, I will write these things if you face the error. Okay, now .kube config
I
added
think
multiple clusters.
it was not saved, I think. Here you have made to beta 1. No?
Yeah, actually, when I updated the configuration, it changed. Let me remove this first. And then I will get the config file again. Here, let me get beta. Oh, I changed it to beta, right? There is some problem which came recently, actually, May 5th. We followed already this approach, but still facing the problem. For him, it is AWS CLI plus updating config helped, but that did not help for us. Okay, let me try once again. kubectl get nodes. No. Okay, let us update the kubectl to another version. Is the version here? 524.1. Now let us try kubectl get nodes. Okay, so I will just write the versions kubectl latest version you use, and we need to follow this article to update the AWS CLI and the config and this one. Okay, just remember I will paste this in README. Okay, finally we got 3 nodes of EKS. These are all worker nodes. Okay, we will not, AWS will not give you the master node access. Master node access is managed by the AWS. That is this one. This is the master node. Okay, you cannot see anything from the command line. All these are worker nodes. Now let us discuss something called node affinity, pod affinity, and then labels, node labels. Kubernetes node labels. Okay, let me create that. Okay, here if you will have some nodes generally, show labels. So these are all the node labels. Usually we have the labels for the pods. Similarly, you can have labels for the nodes also. Okay. Whenever I do some pod, for example, let me take this pod. I don't know which pod it goes, right? It can go to any of the pod. This pod can goes to any node, that is up to the scheduler. kubectl apply -f01. Okay, I need to copy this configuration. Okay, copy this and then you need to update here. Okay, here beta 1 may not work. Let us see. Okay, just make it alpha 1. Okay, don't worry about this. They may clear this in future versions. Okay, now I'm getting out of Minikube. This is going to EKS actually. This is the kube config I updated to the EKS. Okay, pod created. Just see kubectl get pods. Okay, now it is going to 192.68 this node, but we haven't asked Kubernetes to schedule the pod to this node. Kubernetes randomly selected this one. But what if you want the pod to go to one particular node? Okay, so in that case we have the node labels. Now I will label these nodes kubectl label node. One is web, one is app, and another one is database. Okay, let us label like this. For example, now I'm running some database pods. All the database pods I want to go to this node. I'm running some Nginx. All the front end pods I want them to go here, and then backend pods I want to go them here. Okay, so there is some business case also involved in this to reduce the costs. We will discuss it. For now, let me label this as kubectl label syntax. You can see here kubectl label node, somewhere it will be there. Labels and selectors. Kubectl Kubernetes label nodes. Node labels. Okay, I think the command is this one. Kubectl label node kubectl label node, and this one I am making it as tier equal to db. Okay, I labeled it. You can just get to see 216, somewhere it should be tier equal to db. Now I will let me delete this. Now I will select MySQL. I want all MySQL database related pods go to this node. Okay, 216. How can I select these? You can have node selectors. That is it, node selector. Yeah, this one, node selector. Which node I want to select based on the label db. Okay, now you are telling scheduler, I want this pod should go to the node wherever the label is tier equal to db. Okay, now let us do kubectl get pods -o wide. Now you can see it exactly went to this pod. That is through the node selectors. But there are some limitations also. Now if I give some label which does not exist by mistake, let me remove this first. Now if I give some wrong label, what happens? Scheduler is not able to find the node with that label, so it is in pending state. So while choosing this node selector, you have to be very careful. These labels should exist on the nodes. Okay, this is the limitation. With this limitation, we have something called affinity. You can select nodes to the pods using node selector. But can I do the opposite? I don't want pod to go to particular node. This is called as affinity actually. Usually mean the meaning. Affinity means interest. Anti-affinity. This is called anti-affinity. Not interested. There is no way through the node selector. You cannot choose the node. Okay, that can be done by anti-affinity. So due to these limitations, we have the concepts called node affinity and node anti-affinity. So this is the basic one. If you want your pod to go to the particular node, you can select node selector. But if you want more control, you have to choose the concept called affinity. Node selector cannot support this. Okay, now let us discuss affinity and anti-affinity. This one, node affinity. Required during scheduling, ignore during execution. So there is two concepts, node affinity. Okay, now I want my pod. Node affinity means positive. Required during scheduling, ignore during execution. There are two things, scheduling and execution. Required during scheduling means it's a mandatory, hard rule. If Kubernetes is not able to find this, then it cannot schedule. Preferred means soft. If Kubernetes scheduler is able to find this, then it can do. Otherwise, it can select one random node. That is the difference. Required means mandatory, preferred means not mandatory. And then ignore during execution. Execution, there is two parts, scheduling and execution. Scheduling means Kubernetes will schedule it, and by the time it comes into the running, there is some time, right? Within that time, if somebody changed the node labels, then it's fine, it will ignore. Here only scheduling is important, execution is ignored. There can be required during execution, required during scheduling, required during execution, but it is not done by Kubernetes. It will come into the future. Preferred during scheduling, preferred during execution. These combinations, we can have four combinations usually. One is, I can write this one, mandatory rule while scheduling. Ignore at the time of execution. Execution means while the pod coming into the running state, if somebody changes the node labels, then it will ignore that. And then what is the another approach? Preferred. Soft rule. Scheduler tries to match. If not available, it can select another pod, another nodes. Okay, this is the one. In future, you will get required during scheduling and then preferred during execution. Those combinations will come, but these are the things for now. Now let me get this. Okay, we will see the first one. What is our key? For now, we have tier in DB. Okay, you can have multiple values also with in operator and operator. There are some operators here. Okay, with this you can check. Now I can give Nginx and Nginx. Okay, let me delete this. So obviously it goes to the same 216. Okay, crash loop back off is because image Nginx, correct, right? Error, what is the error? Okay, this is not, the name I have given is with node affinity. Let me delete this first. Okay, I'm applying this one, sorry. Okay, I need to apply the second one, right? 02 and the node affinity. Let me give node affinity and then apply. So it went to 216. Now there is something called anti-affinity. Now let me create another pod. Anti-affinity means operator. You can see here, you can select not in operator. Now I will select not in. Now this scheduler will do it wherever the nodes which don't have tier TB. So with this operator, now I am making it into the anti-affinity. Okay, there is no exclusive node anti-affinity actually. You need to use the operators to create anti-affinity. Now this should go to the node wherever it don't have these labels. Okay, now let me write it here, node anti-affinity. Now let us see this another pod should go to other nodes. Okay, you say this node anti-affinity went to another one. These are mandatory rules that is required during scheduling, ignored during execution. Any doubts still here? Is it confused? Okay, then we go for prefer during execution. Preferred is if it don't match also earlier when the label was not matching, pod was into pending state. Now it will not go to pending state. Let us see that. I am giving in some wrong label I'm giving. But if you give like this required during scheduling, since scheduler is not able to find this label, definitely it goes to pending state. Let us see this combination also. This is node affinity hard rule. So simple combinations. Initially it may confuse, but if you practice, then it will give you good understanding. Okay, now you see it is pending because I said required. Now let me give preferred. This is soft. Is there anything wrong with the syntax? Okay, you should have something called something like this. Preference. Okay, the syntax is little changed between required and preferred. There is something called wait. And then here you give tier. I'm giving the value as wrong value, which is not available there. Okay, you see the soft is into running state because this is the soft rule preferred. It will try to match. If it don't have, then it will select one random node. These are the combinations actually. Now you have more control. You can exactly tell where your pod should go. Or if something is not available, then you can let Kubernetes scheduler to select the pod, to select the node for the pod. Okay. Any doubts still here? This is the node affinity. You can select the node or you can hate the node. You can tell Kubernetes, I don't want this node at all through the anti-affinity. Anti-affinity is nothing but not in operator. Okay, just practice this. Similarly, node affinity, we have another thing called pod affinity. Pod affinity and pod anti-affinity. So we have some real-time use case for it. We can discuss in tomorrow's class. Any doubts? Okay, start creating the cluster and then start practicing.
Okay, bro.
Okay, Funny, you have any doubts, Abhishek?
Not sure.
I don't see you guys are practicing it. Abhishek, did you create the cluster?
Yes, yes.
Practice, but doing it, I get inquiries.
Funny, your voice is not clear.
Hello.
Yeah, yeah.
Oh, I have tried to some part, but when I'm trying, if I get any queries, I will ping on the Slack.
Yeah, yeah.
Okay.
Just try to cluster and connect to it. Then later you can do the practice.
Okay, sure.
Okay, then that's all for today. See you in tomorrow's session with pod affinities. And later we can move to the services, deployments, more topics.
Okay,
Sure,
bro.
bro.
Okay,
Thank
have
you.
a nice day. See you. Bye bye.